Hello everyone, so in this video we are going to look at the concept of non-max suppression. So let's take an example. Let's say this is our image and there are two dogs over here. Okay, so the first dog is having let's say it's being predicted by faster RCNN or YOLO, whatever algorithm is being used. It is predicting 3 bounding boxes for the first dog. Obviously 3 bounding boxes is it's let's say it's less, but in reality you'll have a lot more. However, for this example I'm just using 3. So the second dog is over here. This is also having 2 bounding boxes. Okay, these are all predicted bounding boxes even though the color is different. So let's concentrate on the first example. So it has 3. Now we can see that there is only one dog over here and it is being predicted by 3 of them. So how can we get the most important one? Now you would say get the highest scoring one, that is 0.91. So you can see the scores are with each and every bounding box. So the first bounding box is 0.91, here the second one is 0.86, third one is 0.44, and for the green ones as well. So this bounding box is having the score of 0.61 and this one is 0.72. The one way of saying is, okay, we will take the highest amount. But the problem is, we as humans know that this is one object and this is second object. The computer doesn't know. So for it, 0.91, 0.86, 0.44, 0.61, 0.72 is just for all the just in one order. But we can see that these 3 are for this object and these 2 are for this object, but the computer cannot see that. So the problem of NMS, the problem NMS is trying to solve, or non-max suppression is trying to solve, is to make sure that one object only has one bounding box. That is the whole problem of NMS. So what will be our solution? Our solution should be 0.91 is the highest for this and 0.72 is the highest of this. If we just take the highest, you will only get 0.91, 0.86, because again we as humans can see these are 2 objects, these are 2 dogs, but the computer doesn't understand. So let's see how we are going to solve this problem. So the algorithm that we have to follow is, the first step of the algorithm is take the highest confidence score box. So let's say this is from some different example. I'm not using the 2 dog example. Let's say we have got certain boxes and each box obviously has a score. Okay, and this is our final boxes. Okay, this is what we will be taking as output. So the first step was take the highest confidence score box. So obviously if you see over here, 0.94 is the highest, which means our fourth box is the highest. So what we will do, we will take this one. Now the second step is delete the highest confidence box. So over here we have deleted because it was the highest. Now we'll go to the next step, that is find the highest, find IOU of the highest confidence box, which was the fourth box, with all other boxes. So find IOU of this box with all other boxes. So you can see the IOU is over here. So for the first one it is 0.05, for the second one is 0.84, for the third one is 0.49, and so on and so forth. Okay, so what I have to do now is I have to go for the next step, that is delete those boxes with IOU greater than the threshold. So let me assume the threshold to be 0.5 and I have to delete all of those boxes that have higher threshold than 0.5. So this one has greater than 0.5 because 0.84 is greater than 0.5. You can see over here 0.66 is greater than 0.5 and 0.90 is greater than 0.5. So I will delete all these boxes. Okay, so let's delete all these boxes. So these are the boxes that we are left with. Now what we need to do, we need to do step number 5, which is repeat step 1 to 4. Repeat all these steps till we have no boxes left, which means here all the boxes are gone. So again, what is the step 1? Take the highest confidence box. Over here you can see which is the highest, 0.65 is the highest. Okay, so you will take 1. So obviously 1 will be over here. Now the second step was delete the highest confidence box, which means we have to delete this one. So we have deleted this one. Then we have to go to the next step, that is find IOU of the highest confidence box, which is this one, with all other boxes, with the recent highest confidence box, that is this one, and then find the IOU with all other remaining boxes. So let's say with this IOU was 0.67, with this it was 0.08, and with this it was 0.05 or 0.45. Okay, now what was the fourth step? Delete those boxes with IOU greater than the threshold, which is 0.5. So obviously the threshold here is 0.67. Sorry, the number here is 0.67, which is greater than 0.5. However, all these two are lesser than 0.5, which means 3 will be deleted. So you see that 3 has been deleted and then the 2 are left. Obviously the dot 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 here means there are many more. So I am going to leave it till here, and you get the thing, right? So this is how you are going to use it. So let's see one problem over here, the what problem can come. Okay, this basically means that we have to again repeat it till none of the boxes will be present over here. Okay, so when you will do, you will get some of the boxes. So 4 is selected, 1 is selected, then maybe some other will be selected, and this is how you will end the program. But there is a problem, and the problem is something over here. Okay, I want you to concentrate on the green box and the red box. You can see the confidences are very high. Why? Because there is actually a prediction. But when you will see, when you will apply NMS, you will first take the highest, so this blue box will qualify. But what happens when you have the green box? When you have the green box, it will be taken as one of the highest. Let's say instead of 0.92, let's say this is 0.88. Okay, let's just assume I should have made some I should have made a change, but again the NMS will still hold. Okay, so let's say this is 0.92, and what it says is now you have to find the IOU with this with sorry, of this box with all other boxes. You can see with this red one, it will have a very high IOU, at least greater than 0.5. What it means? That this box will be deleted, but this box actually refers to a horse, which means this is the correct box, but the NMS algorithm will delete it. It means that we need to use the threshold which we took at 0.5. It is not, like a one threshold for all the problems. No, you have to actually experiment and see. Okay, so that is one problem which I wanted to show you, that 0.5 has to be seen according to your data set, and it is not cast into stone. Okay, so I hope the problem of, or the concept of NMS, the non-max suppression, was explained clearly. The code for this, actually I'm going to post another video just after this. It is almost ready. So in that I'm going to use NMS. So that will be basically fine tuning of a faster RCN. So I hope you understood the video, and bye.